very honored to get to introduce Kelly Krause, who is the creative director of the magazine Nature, where she has been for 5 years. And before that, she spent 4 years with the magazine Science as the creative director there. Her background is in design, and she currently lives in London, but grew up in the North Carolina area, and that's about as much personal details as I know. All right, without further ado, Kelly Krause.
Hello, yes, good afternoon. Thank you all for coming. Can everyone hear me okay? All right. So at this talk, I'm going to sort of go over just a very general visual framework for nature. And then there's another talk at 3 p.m., which is more specifically about information design for scientific figures. So I'm just going to touch on that, but that's not what this one is, in case you've come to the wrong one. So in a bit of an introduction, I wasn't quite sure how wide the audience would be in terms of your background. So forgive me if everyone knows what nature and science are. But if you don't know, they are scientific journals, and they are among the oldest. So I've been at both, and so at Nature for 5 years, at Science for 4. They're both weekly, so I've sort of been at the helm for over 450 issues. Which when you do the math, it's kind of that's like 90,000 pages of images. So I've kind of seen it all, and so I'm here to tell you about it. The kind of what sets Nature and Science apart from other journals is that they're multidisciplinary. So most journals are very specific. So it's a sort of, they stayed in the old tradition of publishing science from all disciplines. And both journals will publish fundamental breakthroughs. So that's sort of what they're known for. And then this is a really important concept to appreciate during the talk, is that they're hybrid publications. So they're half journals, so half peer-reviewed research where we publish the work of others, and then it's half magazine, which is we have our own team of journalists and writers and editors that do magazine-like content. So it's essentially like Time or The Economist, but for scientists. So our audience are scientists. So this is the art team. So I don't do all those 90,000 images by myself. So this was at our Christmas lunch, where if you know anything about Britain, you'll know what we're wearing on our heads. So everybody gets these Christmas crackers, and but that's the team. So I thought I'd sort of start at the basic level to get us sort of thinking about, I'm coming to you from the world of publishing, and thinking about sort of why do we publish? Chiefly to archive knowledge. So this was the very first issue of Nature, one of the first journals. Before that, journals were mostly sort of private correspondence, then read at clubs or journal clubs, or the pre-journal clubs. Then we also published to communicate ideas quickly. I have this particular one because this was a paper that went through very quickly, even before it was printed. So, it's sort of, this is what publishers are tasked to do these days, is sort of disseminate information, yes, and also do it quickly enough so that the scientific community has the information they need to build upon. And then this is really important as well. Publications give us context. So, we have different kinds of things. We have the research article that is peer-reviewed research. We have the review that is more of an analysis of a field, let's say, or we have a news story, or we have different types of articles. So this is Scientific Data, which is part of the Nature family that launched in 2014, which is you can publish just a data set now. So, publishing gives you this very important ability to focus your conversation in a specific way, because everyone has shared expectations as to what the content is. And in this way, visual communication of that content is in context as well. So this is just sort of a really easy example of, I think we've all been stranded at an airport from time to time. So I was stranded at Stansted Airport, which is a little weird airport in London, not one of the big ones. And I was bored, and I was thinking about browsing the magazine rack, and I was thinking how I just walked to the point of the magazine rack that I knew where I wanted to go to without having to look at any of the titles, just by the colors, right? So if you look at that, you probably know where you would go and there's probably a different answer for different people. If you're looking for sort of hobbyist stuff or, the sort of planes and boats and that sort of thing, it's like almost exclusively red and blue is their palette, right? This is like, you don't even have to really read it. If you're looking for gossip, you go to the magenta, right? Like just directly. And if you want some more sophisticated reading, well, it's sort of more varied, and that in and of itself, is a palette that draws you in. In a similar, this is the way it is for all visual communication and publishing, that things are designed for a particular audience in a particular way, so that you don't have to wade through things. You know exactly where to go to find what you're looking for. So in terms of scientific journals like Nature, when we are thinking about visual communication, this is where we start. We're thinking about the audience. And so I've sort of classified them in 1 through 3 for ease of conversation. But so the first is a very narrow scientific audience, really highly technical. These are your peer-reviewed research papers, your research articles, and letters. Then the going about out a bit wider is a sort of wider scientific audience. So this is the sort of analysis and reviews of research, things that in Nature are like the news and views section or the perspective section in Science or that sort of thing. And so the idea is it's still for scientists, but the idea is for a biologist to be able to understand a breakthrough in particle physics, let's say. And then the third thing is it's kind of we call it a halo audience in publishing, but it's for not just the scientists, but also the science policymakers, the science-interested public, the educated lay audience as well. So that's the sort of final sort of layer of the onion, I suppose. And then we ask ourselves, once we identify the audience, then we map that to what is the appropriate visual language in this case, right? So there are different ways of communicating depending on the content. And then, of course, being publishing, we have to be very practical. Everybody wants, especially, if you're publishing a paper, you want it out now, so its speed is the premium. Can we do what we want to do in the time and the budget that we have, the resources that we have? So just to give some examples of this, to go through just different kinds of contexts for visual communication. Here we have research figures, and again, I'm not going to go into detail about this, but if you're really interested, at 3 o'clock, I will. These are technical data represented mostly as evidence and data collected during the research process. And the important thing, for us as publishers of this stuff, is to sort of we respect what I call the vernacular, for lack of a better word, of the visual communication techniques of that field. Because certain fields have very particular ways that they visualize things that maybe don't make sense or aren't best practices in other fields, but communicate deeply in that field. But at the same time, we urge best practices. One of these things that we discourage, let's say, is a rainbow color scale, as you can see in one of the figures here. But an author can make a case, well, there's an important reason why we're using it in this case. So that kind of thing. So again, more about that at 3. Then you have the sort of scientific illustration, which I think we're all, if you're in the sciences, you are familiar with. So it's a simplified visual language is what it is. I think visual language is a science system. I think if you're interested in semiotics and that kind of thing, look up the work of Jacques Pertin, who's the sort of founder of that really interesting work. But essentially, what we are doing here is we are making very symbolic, simple representations for things that are very often complex, very often can't, be seen by, be seen as they would like in a photograph or whatever. So that's, this is the currency of, a lot of analysis pieces and review pieces. And this is, I just thought I would take a quick screenshot of this. This is at Nature. This is our library of cells. It's not, this was just a screenshot of like one, but yeah, so we intentionally reuse the same things, very much like, when you're reading something, you're not looking at each letter, you're just comprehending. And I think like that's the goal for a sort of symbolic visual language for science. You can spot the, the dendrite from the other kinds of cells, or just very quickly and easily. Then now we're sort of expanding to the sort of halo audience kind of thing, where graphics that are called infographics sort of now, that are really, they have a narrative, and this particular kind of infographic here is explanatory. So it's explaining a phenomenon, event, or process in a way that, that kind of was in step-by-step sort of walks you through, and there's a narrative. We have decided for you what we think is important and how to represent it, and we've annotated it there for you. And then I have these little tip things there because that's sort of, if you are creating this kind of content, it's sort of a tip for you. So if you're, if you're working on something and you're finding something is very difficult to explain it in words, those things are very often, it will help you to sort of visualize them and include that with your content. Then we have just sort of classic, data display graphics here. You don't need to say too much about that. But if you are creating something in the story that you're telling is very much about the numbers, then it's a wise idea to include some kind of data visualization in the form of just plain old graphics. This is something we use a lot in our news content, which is the contextual aid, so that maps and background. So very often, we're writing a story that is a smaller part of a larger story. And so rather than having to repeat that in the story, we can do that graphically. Or if the reader needs background or grounding in other ways in order to appreciate the topic, then, we will do. They're very attractive. We very much want them to be eye-catching and sort of appeal to the senses kind of thing for this kind of material. Interactive, I thought I'd just briefly touch on. Interactives are great for exploratory, so rather than explanatory. So when there's a lot of data to be interrogated, and what you're asking of the audience is, here is data, go and make your own story, go and dig deep and find what you want out of it. We do quite a lot of this in data journalism at Nature. The thing is, people ask us about interactives for research, and what we have found is as though they're, obviously interactivity is a tool, especially with the increasing data load, right? Data visualizations for, interactive ones support layers of information in a way that a static figure cannot, but they are incredibly hard to archive. So we have sort of moved away from supporting interactive figures ourselves, and very much like to partner with and have the author or the institution or whatever, we will link out to the data in other places. But imagine if all of the figures it made 6 or 7 years ago were in Flash. Nobody uses Flash anymore. No one would be able to use it. So it's very dependent on software. So for the peer-reviewed stuff that's published, we tend to stick to static figures, but interactivity is obviously very important and fits a certain profile of exploration. Here we have the sort of more glamorous stuff, the stuff that tends to make it on the cover or be in high-profile, sort of news stories or things. So this is scientific artist conceptions are, the interpretation of someone, it's based on data, right? So that's why it's a scientific artist conception. But it is very much an imaginative process, very often sort of trying to capture something that we can't experience or that has been lost. In the case of this cover here, that was an ancient Devonian forest in New York that we were able to recreate from the fossil record into this to just try and bring you, it is a kind of emotional thing, isn't it? To try and bring you somewhere that it wouldn't be possible in any other way. And then this is the last thing, this sort of classic editorial illustration. So we do this a lot we have a sort of opinion pieces where we, where we will say, listen, NIH, we think you should do this, or that sort of thing. And so it's this is perfect for editorial illustration where it's essentially, a concept art that goes with the piece. And I thought I would just touch on aesthetics, because it's something that, especially in conversations about art and science, comes up quite a lot. And just try and build a bit of a framing or find the edges of that a bit in case, asking questions or whatever, it might be useful. And so what do we mean by aesthetics? And I think, it depends on who you ask. So I think for scientists, particularly computer scientists, in data visualization experts, they tend to go closer to the origin of the word, which in the Greek is more about perception. And it's sort of mapping sensory attributes such as color and form and these things to data to enable us to be able to perceive it. And I'll show another slide to sort of show you what I mean. But that tends to be, more about, we have these numbers, let's map it to something that allows us to perceive it in a different way that helps us comprehend. And I think, so that's in the realm of the sciences. I think that's how aesthetic attributes are described. Then you have the sort of popular usage. So I think if you were to go out and ask someone on the street, what does aesthetics mean? It would probably be beauty or taste or something that is aesthetically pleasing would feed the senses in some way. And then you have a sort of a different take on the word, which is a field in of itself of philosophy and fine art. And it's these sort of questions about, what is art? Who makes art? What makes it art? And so I think like this last slice is not, we in publishing don't really touch on that much because we don't really question that. We have a sort of context, we communicate it, and that kind of thing. But I thought I would bring that up in case there's anyone here from that background. That this use of aesthetic is not the usage that I tend to ascribe to the work. It's really the first two. So sort of going back to the idea of aesthetic as perception. Anscombe's quartet is a really famous example of this that you may have seen. Where you have 4 data sets, and they're all statistically similar. And but so I can let you look at these, and maybe you can visualize the patterns. So creating visualizations it's all about pattern creation and understanding the patterns in the data, which is why we graph them, why we create abstractions. When you graph them, they look pretty different, and it's actually very easy to see the patterns once graphed. It's very easy to see the outliers, in the general pattern. So, and this is just a quick kind of real-world example. So small changes to aesthetic attributes, such as line width, can make a big difference. So in the example on the left, there are the same line style is used for different things, whereas if the one on the right, it's more discriminating, so different lines that serve different purposes are actually different, and there you can see the pattern pretty much right away. So that's sort of, the aesthetic attribute to enable something to be perceived so that it can be comprehended. So I thought I would take you all through some case studies from nature that sort of look at how we deal with visualizing science in different ways in different contexts. And so it will start, with the research paper, and then what we've done in other sections, and then what we've done on the cover. And I like to talk about covers not because this made it onto the cover, but because it is a single image that encapsulates a lot of ideas, and so you have to use visual metaphors. There is a burden of a cover to be beautiful, to be in the aesthetic way, to draw one in, to be aesthetically pleasing, as well as to be, because it is science, to be, to have integrity as a visualization itself in terms of representing accurately the science or not misrepresenting it in any case. So this was a paper that we published on the mapping our home supercluster of galaxies called Laniakea. And this came out maybe about a year and a half ago now, I'm trying to remember. And it was the first ever mapping of our home supercluster. This was one of the figures from the paper. I don't know if you can you see the supercluster? This turned out to be one of the extended data figures, but this was submitted to us by the authors as a cover submission. So this is what they proposed that we put on the cover. And as you can see, so now usefully, unlike the last one, the orange border is basically communicating to you that this is the boundary of the supercluster. And then you have this sort of rainbow thing going on that's actually a density map. And then the lines are velocity flow streams, and that's sort of how these superclusters are organized. I can't go into it any farther than that. So we took a look at this and sort of were like, this is an amazing paper, this is really interesting, but when I look at this, I don't see supercluster. I see like this could be some kind of, I don't know, cardiology thing or something, you know. But we were very interested in featuring this paper on the cover, so I asked the author to maybe make a few adjustments. So first of all, to put it in the aspect ratio of the cover, but also to strip out the rainbow color scale, because that's not helpful, I don't think, in trying to understand the density. I think you can show it using grayscale, and grayscale, kind of once you see it in grayscale, you can understand the information, I think, a bit better. And then that also kind of puts to mind of the darkness and the singularity of the background in putting it in sort of one's mind's eye in outer space somewhere. And also, so this is what they came back with, which I think was a big improvement, but not quite there. So then I took their thing and did a quick kind of sketch of, instead of making this line around, can we make it a sort of a form that's sort of subtle, but there you can see the boundaries, but it's in a shape and it's not just a boundary. And can we make it? Can we give the stars a bit of glow so they're intuitively stars? Can we make the galaxy look? Can we bring light to it, basically? And so we asked them if they could do this, because they're using all of their they're doing all this in their modeling program that they built for their experiments, and they're like, this is a great idea, but it's sort of beyond us. So so what we do in these cases is that we work with specialist artists. So there's a specialist artist that deals just with astro named Mark Garlick, and so we gave him this brief and we showed him this, and I was like, can you do this for us in like 5 days? And and he said yes. So this is what we ended up with, and I think it when you look at it, you intuitively understand, hopefully, that this is something way beyond us. Universe, galaxies. We did something a bit playful for nature, which is we did a you are here. We located us in our home supercluster, and we're not even at the middle. We're like at the very edge, which is really humbling in a great way. So that's the sort of some of the processes that we go through for a cover. This is another sort of interesting. Kind of ended with a sort of creative cover case example. So this is a paper last year on geology about defining the Anthropocene. So essentially making the argument that we're currently in the Holocene, that the Holocene's over. Because of human activity, we have launched ourselves into a new geological epoch. And so there are formal requirements to declare a new epoch. And those are global scale changes in, air, water, soil, ice, that kind of thing. And so, these are what geologists have used over time to declare the different stages of time. And this is an interesting, like vernacular kind of example, because this is a figure from their paper. And, geologists do time vertically, and it's sort of, a lot of timelines are horizontal, if you see, as a timeline. But they do it because that's their practice, right? They dig and and it sort of like mirrors their practice. And so I think that's kind of a nice example. But so we have this, and they're basically, the researchers are essentially saying, look, we have 2 different kind of ideas about, actually I'll show you this, about when the Anthropocene starts. So in this useful table in their paper, they say, that here are some major human activities that could have launched us into the Anthropocene, but they eventually go on to say in their paper that they have chosen 2 as their kind of favorite options. One being the new old world collision. So in the 15th century, when shipping began between the Americas and Africa and Europe mostly, that changed. There were exchange of not just species, but of everything, of pollen, of things that fundamentally changed the Earth in a way that have launched us into a new time. And then the other one is the nuclear age. So there is enough radioactivity detectable in the Earth that at any point that has launched us into an official geological new epoch. So here on the left was another figure from the paper, and the figure is basically saying, here's our data, have a look, which is what, a research figure does. And then on the right, this was what we did in a news story. So to visually communicate to a wider audience, we did all the work, and we were like, look, here are the two things that they think. It's either this sort of late Anthropocene thing, this early one is nuclear mostly, the other one is about farming, so it has set everything out in a sort of narrative. We've decided what the story is, and we are telling it, and it's more of a passive experience on the part of the reader. And so when so these are maybe subtle but very different ways of communicating. And I think if you were to say, let's annotate a research figure in this way, that's not really part of the culture of a research figure. And then when it came time to think about what to do on the cover, going back to this table, we thought about, well, should we do photography? Should we do, a picture of, let's say, an aerial shot of a really cool pattern of farming where you can see the human impact on the earth itself? Or should we do an urban scene with just seas of people? Humanity is just taking over. We're thinking about it. I felt strongly that it shouldn't be interpreted as a sort of political or environmental message. I think that is for someone else. We are a scientific journal, and we're focusing on the science. We're focusing on the process of the science. And so I really wanted to tell the story of the science on the cover, which is really boiled down into this table. And so essentially what I wanted to do was visualize this table. And I thought that there was kind of, this is where the sort of, crossing over into is it art? But it has this sort of meta thing about it, where here we are as humanity judging ourselves and determining that as humans we have done enough, I wouldn't say damage, but enough to the earth to have launched it into another time. We're essentially judging ourselves, and which hasn't been the case with other epochs, right? We're judging, mass extinctions in other ways. So I thought it would be interesting to sort of map or sort of tattoo some of basically the story of humanity onto a person, a symbolic person. And so this is what we commissioned it to an artist who does this kind of work. And this is sort of what we came up with, and the idea being to engage a wider audience, and to to have people really look at it and ask questions. And so and it is very much the table. So if you go up the right arm, it's the sort of agriculture, and then we've used the exact crops, the rice and the things. And as you go over, the torso, it is a lot of the old world, new world kind of things, and with the with the ships of the era and that kind of thing. And then going down the other arm, you have the Industrial Revolution kind of argument, and then ending up with the sort of nuclear argument there up on the shoulder. And so it's sort of how in the process of tattooing we change ourselves, and so that was the sort of visual metaphor there. So that's sort of a very different method of communication in a different context. This paper came out quite a while ago, but it's one of my favorites. The publishing of the human microbiome, and so they had some very nice figures, a lot of data, and obviously, which was presented well. But we decided to, when doing the sort of analysis piece, to make it super simple, it's old news now, but but at the time it was kind of surprising, the numbers and of the different bacteria where and that kind of thing. So and just I think for people beyond the field, the idea of just how sort of our microbial selves, it's not something alien, it's part of ourselves, So we were trying to think of a way to make it a sort of friendly message of a sort of mirroring ourselves. So we have ourselves and we have our microbial selves, and so the authors actually came up with this. I can take no credit for this actually, other than just the idea. But so it's I think beautifully rendered and a sort of gives you that sort of fellow travelers, mirror kind of way. And then, of course, because it's science, all the microbes are the microbes in the paper. And this is my last example. This is a somewhat recent paper. This came out in the autumn. And this was an interesting paper because it's the first ever map of tree density globally. And you would think, well, don't we already have maps of trees? and the answer was we did, but they weren't very good. So we had, they were all based on satellite imagery. And then this paper was a real breakthrough because it was actually based on ground counts, people actually going out and counting trees, plus the satellite images. And so what we found is that we had grossly underestimated the number of trees on the planet. So until this came out, we thought there were, I think, roughly 200 billion trees. I mean, this showed that there are around more like 3 trillion trees on the Earth, which is good news. I think, that we have more trees, but also this is really important because for conservation, because it was showing that we are cutting down 15 billion trees a year, which is not sustainable. So it's not all good news, but this is a really breakthrough paper in a lot of ways. And so this is one of their figures kind of explaining their process. And they ended up, their data set were in pixels, and I used to remember, and I can't remember the exact science to be able to explain it very well, but they had a very sophisticated model of how to compile the map, and this is the map, you see. And so the map is really impressive if you understand the background I've just told you, but if you're just coming at the map, it doesn't really look like much, doesn't it? It just kind of looks like a topography map, So we I was thinking we really need to do something different with this. It's so interesting. And so what we did was we were able to, the author of the paper was really great, and I said, could we hire a data visualization expert to work with you to take your data, put it into a format that we can work with, and then show it in a way that's more impactful, that can show the science a bit better. To more people, really, people outside the field. So this is what we did. I'll just show this. There's supposed to be narration with this, and maybe there's something wrong with the file. Okay. The video is on YouTube with the narration if you want to look under 3 trillion trees. But essentially what this is so we worked with, his name is Jan Willem Talp, and he was able to map the trees, and he used an algorithm that basically did it with color and with height. And the height being a sort of intuitive thing if you're thinking about trees that are, and then the striking thing about this was we decided not to put any other information on it, right? So you see these areas, like the Sahara, that are essentially, they disappear, and so there's a completely different view of the world than what you. So I'm sorry. I think I must have. I don't know. This is anyway, but but it makes sense without the narration, maybe. So this is I think animation. So I included this example because 3D work and animation is it's time consuming and it's expensive, but it can it's a really effective tool for visualization if you have the time and the budget for it. And so I thought, this brought a greater audience to the paper, which was good. And then I think it just helps people intuitively sort of see the map. But yeah, we can stop this because this is, unless you keep going. No, let's stop it. So, you know what? I should let it go because then you can see. These are the people actually counting the trees. So we did a sort of reel of the researchers doing it. So then for our news, we knew this paper would get a good amount of press coverage, and we wanted to make sure that we had accessible information for that sort of halo audience. So we did a sort of a 2-page infographic that had even more information. Like from the paper, we took information from the paper and made it into graphics. And then, of course, the cover. So thank you. That's all I have. Thanks.
How much time do you get to work on each issue? Each issue seems very complex, and you're obviously doing it every week. So how long does each issue take?
Yeah, that is a difficult question to answer because we work on several issues at once. So we don't ever have a time when we're finished and we're like, yay, let's all go out for drinks. You know what I mean? It's like, oh, the issue's closed. It's it's just continual. And because it's the research naturally goes on a sort of separate schedule from the news stuff. We have a big team because we have 200 pages a week. It is a lot of content, but that is it's like how long is a piece of string kind of question. I'm not sure how to answer that. Yeah. Oh yeah. So no, I mean so for the average, let's say, news story, we have about 2 weeks to work on it. So that's for the that's for all for the average like news and views sort of analysis piece or whatever. We have about two weeks to work on something like that, and that's not full on. That's just the planning from So we like from the art perspective, we all of us are all working on different sections all the time. So it's quite an operation, I should say. Yeah.
Thank you.
Is this on? I'm very curious. Wonderful talk. I'm curious about whether you gather metrics to measure somehow the impact of your visualizations on the understanding that people have. For instance, the video or something like that, to then feed back into the process of what do I do for the next piece of art.
Yeah, that's an excellent question. And the answer is we don't really have a framework for gathering feedback other than the classic kind of focus groups that we will do. And we always ask about visualizations. Like any media organization now, I think judgments are being made by how many people visit a certain story, right? So page views and not just page views, but engagement, let's say, time on a story online. But those things are hard to quantify, and they take we don't have a sort of like analytics team just for visuals, but we do have an analytics team for like the whole journal, essentially. Yeah.
So I really enjoyed the example of the supercluster, kind of walking us through the evolution of that. But I guess that raises the question for me: how do you decide when something is its maybe not, I'll say, best in quotations?
Yeah. Yeah. So that's a good question, and I think it's important to understand that all visuals are representations, right? So design choices have to be made for everything. And I think there is a framework for, I think, for something like a cover, there's a bit more leeway, I think, in terms of the design decisions that can be made, versus doing something like a scatter plot, although there are design decisions to be made during scatter plots. But I think that it all comes down to just be trying to make the best decisions that you can make to represent the science in a way that's engaging, and at the same time has integrity. But yeah, it's just I think for things like a cover, maybe not everyone's going to like everything, right? And there will be disagreements, but that's okay because it's not the final word. It's just a representation. I think that's something that scientists tend to understand, the general public not so much. So I think that is a conversation that should be had, I think, in a more sophisticated way with the general public when seeing things like, let's say, images from a Mars rover, let's say, or, like, I don't think they understand that that's really just sort of numbers coming down and then reinterpreted through algorithms, and like the way that we interpret visualizations, you have a human making design choices at the end of the day, so.
Could you talk a little bit about the amount and nature of communication you have with the scientists who do the research and give you the data and your design teams?
Yeah, certainly. So we engage with the authors after the paper has been accepted. So we wouldn't, let's say, advise them on figures before that. And then, once a paper has been accepted, then we receive their draft figures. And, for when you're publishing someone else's work versus creating our own, we have to respect that this is someone else's work. So we tread very lightly in the case of a research paper. And, we just sort of, we make sure that, we feel very strongly that the world's best science needs the world's best figures, right? So we will we'll rekey things and, line things up and make sure that things are organized and high resolution and all of these things. But we will not redo an author's figure. We will make suggestions. We'll point them in the right direction. Whereas that's, when it comes to something more like an analysis piece where an author, it is really co-creating with the art department in a more meaningful way. So, let's say you have a news and views piece that's sort of summarizing a paper, and we really just want to do one kind of summary figure, maybe not just for the paper, but for like the state of that field, let's say, and how that paper fits into it. That's really more of a conversation about the best way to interpret something visually. So really it kind of depends on the context.
So I was wondering if you're seeing any trends in what you're receiving from authors in terms of figures. Are they becoming more sophisticated, more ready for print, or no changes over the years that you've worked?
I would say in a sort of grand analysis, there hasn't been that much change. But since I started, I started sort of after the era of like desktop publishing and that kind of thing. So I think the tools drive the output a lot, and I think that the tools have been roughly the same in terms of what is printed in a sort of static figure in a magazine. I think the kind of stuff that we don't do, let's say the genome browsers and the big data sets that are hosted by the institutions, I think that is very much a moving target. And the sort of visualization tools that the authors themselves are using are more sophisticated. But the figures tend to be about the same. I will say, though, that there's a lot more data being published in the form of supplemental data and extended data, and that is a big change. And I think there's a pressure to show all the data that you have. It's hard won. You just want to show all your data, and I think that's slightly new. Yeah.
Hi, great talk. I was wondering if you could share with us any information about some of the data visualization designers you've worked with and maybe the tools they use. It seems like maybe the tree one might have been created in processing. I don't know if you could share any information about that.
Yeah, so the tree one, okay, so here do you see there's naturegraphicstumblr.com. So that is, we don't update it quite as much as we should, but we do have some really good examples there of like how things were made, and we actually had Jan Willem write a step-by-step of actually what he used. It wasn't processing, but I can't remember off the top of my head. So that is there. So we, so do you like specific names or, I don't know. The thing is we have a lot of great in-house talent. So because of the nature of the work, a lot of the stuff is embargoed. It's not easy to have someone on the outside work on some of the stuff. I would say most of the work we do is actually in-house. We do like something like in the trees case, we needed outside expertise because it was not an easy process converting the author's data into a usable format. So yeah, I would say we tend to do a lot of stuff in-house, honestly. But yeah, check out the blog. There are a lot of, it's all about how-tos. How did something happen? So yeah.
I'm curious in hearing a little bit more about where you draw the line between the different approaches for passive reading for your news articles versus for scientific figures. Is it in fact the culture, or is it perhaps just lack of interest in that? Is it necessary to keep that approach for scientific figures?
That's a good question, and it's a real controversial topic. Yes, so there have been lately a lot of interest of designers that are not from a scientific background necessarily, but information designers looking at scientific figures and being like, oh my God, there's this cult of ugly and horrible, and so you should be, annotating things and storytelling and all of this, and it's there's a Nature Methods does a column called Points of View. I don't know if anyone's familiar with it, but I'll be talking about it quite a lot in the next talk. And there was actually an article on storytelling written by Alberto Cairo, who he's a sort of data visual guru that came out of journalism and now engaging more with science. And it got a lot of feedback, and a lot of it was not positive. A lot of people were saying, look, the role of the scientific figure is not to tell a story, it's to present the data and let you come to your own conclusion. But then, designers, quite rightfully so, come to some of these data visuals and figures that could really be improved that are not doing the data justice at all, right? So it really depends on who you ask, but I think, we err on the side of drawing pretty firm lines, in terms of the research figure being is not necessarily the place for narrative and storytelling in an explicit way where you sort of say this is point 1, this is point 2, this is point 3, so yeah, but it's really interesting, and there are gray areas, of course, right? There are like, yeah, I'll stop there. Yeah.
Well, if there are no other questions, then let's please thank Kelly Cross again.